Nintendo does not talk about how their products are made. No factory tours. No behind-the-scenes documentaries. No leaked assembly line footage. They are one of the most secretive manufacturers in consumer electronics, and they have been for decades. But what we do know about how the Nintendo Switch 2 is built is genuinely fascinating. Because underneath that familiar feeling, plastic shell sits a level of precision engineering that most people buying one will never think about for a single second. So today we are going inside the assembly line to break down exactly how the most anticipated gaming device of the year gets built from scratch. The shell of the Switch 2 is injection molded from a high-grade polycarbonate and ABS plastic blend. Injection molding machines force molten plastic into steel molds under pressures that can exceed 1,000 tons of clamping force. And the molds themselves are machined to tolerances tight enough that every single shell that comes out is dimensionally identical to every other one. The wool thickness of the shell is engineered to be as thin as possible to save weight, while still being rigid enough to protect the internals during drops and everyday handling. After molding, every shell gets inspected for warping, sink marks, and surface defects, because any dimensional imperfection in the shell causes fitment problems when the internal components get assembled inside it. The heart of the Switch 2 is a custom NVIDIA system on chip built on a cutting-edge process node that packs the CPU cores, GPU cores, memory interface, and all the supporting logic onto a single piece of silicon smaller than a postage stamp. This chip gets mounted onto the main logic board using a process called flip chip bonding, where the chip is flipped face down and its solder bump connections get reflowed directly onto the board. Pads in a single precisely controlled heating operation. The board then goes through automated optical inspection, where camera systems verify every single connection point before the board moves forward. Any board with even one suspect joint gets pulled for human review, because a bad connection on the main processor board means a device that crashes, throttles, or fails entirely in a customer's hands. The Joy-Con controllers are where the assembly process gets particularly impressive, because each one is essentially a complete independent device. Inside, every Joy-Con sits its own processor, its own Bluetooth radio, its own accelerometer and gyroscope, its own battery, its own set of buttons with individual tactile switches underneath each one, and the new magnetic rail attachment mechanism that the Switch 2 uses instead of the sliding lock of the original. The magnetic attachment system requires the magnets inside the Joy-Con and the magnets in the console rail to be positioned and oriented with exact precision so that the attachment force feels consistent. The electrical contacts align perfectly every time, and the connection is strong enough to survive the console being picked up by a single attached Joy-Con without disconnecting. Getting that magnetic system to feel premium rather than cheap came down to magnet grade selection, placement accuracy, and the geometry of the contact surfaces, all of which are controlled tightly during assembly. The display is one of the most critical components in the entire device, and it gets its own dedicated assembly and testing stage. The LCD or OLED panel gets bonded to the touch digitizer layer using an optically clear adhesive that gets applied in a clean room environment to prevent any dust, particles from getting trapped in the bond line where they would show up as visible spots or pressure marks on the display. The bonding process uses vacuum lamination to eliminate any air bubbles from the adhesive layer before it cures. After lamination, every display assembly goes through a full visual inspection under controlled lighting conditions, and then an electrical test that checks every touch zone across the full screen surface for correct response. After all the major components are assembled into the shell, the complete device goes through a multi-stage functional test. Every button gets actuated and verified. The display gets driven through a full color and brightness test pattern. The speakers get tested for frequency response and distortion. The wireless radios get checked for output power and connectivity. The accelerometers and gyroscopes get verified on a motion test rig. The battery gets checked for charge acceptance and capacity. The Joy-Con attachment and detachment mechanism gets cycled multiple times to verify consistent magnetic force and electrical contact. Every single result gets logged against the serial number of that specific unit, and any device that fails, any single test does not proceed to packaging. Nintendo has shipped over 1.3 million original Switch units since 2017, and the Switch 2 production line was built to handle demand at a scale that makes those numbers look modest. The machines running that line work around the clock, And the quality control system sitting at the end of it makes sure that every device reaching a customer is built to the same standard as the first one off the line. What looks like a simple plastic games console from the outside is, on the inside, a precisely engineered piece of hardware that went through hundreds of individual manufacturing and testing steps before it landed in your hands. And the moment you click those Joy-Cons on and hear that sound, you are hearing the end result of all of it.